all going to learn about the production with two variable inputs, that how it works in case of two inputs, how it combine, how to obtain the optimum combination of inputs, how a producer equilibrium can be achieved at what level. So that is all about in today's session in Unit 3 in Unit 8 in Block 3. So let's begin the basic concepts, that is the production with two variable inputs. The first concept is that in the long run, all inputs are variable. It means whatever the inputs or whatever the combination of inputs are become change. When the next concept is isoquants. Isoquant shows a combination of two inputs, let's say labor and capital, that can produce the same level of output. That's called isoquants. If any combination of inputs that doesn't produce or provide the same level of output or the same level of quantity that needs to be produced, that's not isoquants. So the isoquants has a condition that any two inputs that can be combined to produce the same level of output, that called isoquants. The next concept is production isoquants, that it shows a various combination of two inputs that the firm can able to produce a specific quantity, or you can say in other words a specific level of output, that's called production isoquant. It means a researcher or a learner or a particular analyst can combine the two inputs so that the firm can able to produce a specific level of output, that's called the production isoquants. The next concept is economic reason of production, which is one of the most important topic. It also shows that the firms will only use the two combination, that means the combination of two inputs in that particular economic reason of production, which refers to that portion of each isoquant which have a negatively slope. It means the isoquant is a downward sloping. So the area which is downward slope, or the area which shows a downward sloping, that exactly the area of the whole isoquants, or you can say the portion of the isoquants, is exactly called the economic reason of production. The next concept is that what the higher isoquants implies. The higher isoquants refers to a larger output, while the lower isoquants refers to a smaller output. It means whatever the combination of inputs, the higher combination of inputs provides a larger output, that's called the higher isoquants, and the combination of inputs that's produce the smaller output, that called the lower isoquant. So these are the four main concepts which refers to isoquants: production isoquants, economic reason of production in the higher and the lower isoquants. The next is assumptions. What are the assumptions when it comes to the you can say with the production with two variable inputs? So these are the assumptions which consistently followed when it comes to a long run basis. So the production function are based on certain assumptions that there is a perfect or equal visibility of both inputs and outputs. And the second one is limited substitution of one factor for another. So whatever the input substitute, they have a limited extent for towards the one factor to another. The third point is constant technology. The technology must be constant. The firms which uses the technologies or the latest technology, that should be in the constant use. And the next and last assumption is inelastic supply of fixed factors in the short run. So whatever the supply will remains the same, or will remains the, you can say the horizontal in the short run. The next concept is how you graphically represents the production with two inputs. So in the above schedule, if you see on the screen, the capital and the labor are the two inputs. The labor is represented from 1 to 6 and the capital is also represented from 6 to 1, and whatever the values which has been described in the schedules that are called the quantities, or in other words we can call the level of output. So if you see on the screen, that is the capital and labor. If we combine the capital and labor around 6 and 1, you will get the output 10. If you combine the 5 and 1 input, you will get the output of 12 units. So these are the combination, and this is the data has been prescribed, which is 10, 12, 12, 10, 7, 3, 24, 28, and so on. And based on the schedule, the isoquant curve with the use of the two variable inputs has been drawn. So if you look at the diagram, in the labor has been measured on the x-axis and the capital has been measured on the y-axis. So if you see the quantities which refers to 12, 28, 36, and 42, these level of output has been drawn because the maximum to maximum, if the inputs has been combined, which produces the same level of output. So these are the same level of output, that the quantities are 12, 28, 36, and 40. So if you see the first combination of two inputs, labor and capital, the first one is 12, 12, then continuously 12, 14, 14, 12. I repeat once again, the first isoquant curve which has been drawn from using the combination of two inputs, labor and capital, and their level of output are which produces the same level of output, that is 12. So 12, 12, then again 10, then 18, then 12, then 14, 14, and 12. So this is the first isoquant which produces the same level of output, that is 12 units. Let's begin from the second isoquant. If you look at the second column, so this, from using the second column, you can draw the second isoquant. You can, using the third column, or by combining the capital and labor, you can draw the third isoquant curve. If you're using the fourth, you can draw the fourth isoquant curve. So from the first isoquant, using the first column by combining the capital and labor inputs. So the first one is 12, 12, 10, 18, 12, 14, 14, 12. So this is the first isoquant curve which produces the same level of output, that is 12 units. So if you look forward to the second column by combining the two inputs, capital and labor, so you can see the same level of output, the maximum units which has been produced, and it remains the same, that is 28, 28, then 23, then again 28, 30, 30, 28. So this is the second isoquant curve by combining the two inputs, that is labor and capital. That is 28 Q. That means the level of output is 28 units. So if you look forward to the third column by combining these two inputs, you can see from the third column the same level of output, the maximum same level of output is 36. So 36, 36, then again 36, 36, 33. So this is called the third isoquant curve, which produces the same level of output, which is 36 units. So let's come forward to the fourth column, which produces the maximum unit or the maximum level of output, which is 40 units. That is 36, 40, 40, 36, then again you can see 40, 36, then 36, I repeat once again, 36, 40, 40, 40, 36. So the maximum units which is being produced by combining the two inputs is 40 units, which is a level of input, level of output. So if you look forward, which is a higher isoquant and which is a lower isoquant, so 12 is a lower isoquant, it produces the lower output, and 40 is a higher isoquant which produces the higher output. So from the schedule, the isoquant curves has been drawn. So, how to draw the economic reason of production? So, if you look the isoquant curve, the particular level which the curve or isoquant curve which has been sloping downwards, so that particular reason is called the economic reason, which will become forward in the upcoming slides. So in this particular example, the labor and capital has been given to you, a schedule has been given to you. You have to use that combining these two inputs and how to draw the isoquant curve using the schedule. So this is a way to draw where if you are combining the two inputs from first column, just look at the which particular unit is having the same produces the same level of output by combining these two inputs, that is 12. And the second column it's 28, third column is 36, fourth column is 40, and the next columns fifth and sixth cannot be drawn as the further data is required which has not been given, and it is not required to draw as the more and more curves will be drawn, the data would require more. So this is the five columns or five levels of output which has been shown by combining the two inputs. So this is the graphical representation of production with two variable inputs in the long run. So you can see that which one is the higher isoquant which represents the higher output. So it is a representation of the higher isoquant. So the particular level of output which is the higher units which has been produced by combining the two inputs labor and capital, that's called the higher isoquants. So if you look at another example which shows the higher isoquants, this would be the third you can see curve which shows in the pink color, and when we talk about the green and blue, it shows the 29 units which is a lower output or a lower level of output, and it also called the lower isoquant curve. So when we talk about the second curve which is in blue line, if you look at the second curve by combining the two units labor and capital, 52 units or level of output, it's the same which by combining these two inputs, that is 52, 52, 52, then again 52 at the last into 8, and 8 units of you can say labor and the 8 units of capital. Then again combining these two inputs at the end also, the 52 level of output has been occurred, has been arised, and as a result it is called a lower isoquant as compared to the upper isoquant curve. So when we talk about the next higher isoquant, that would be the 73, 75, 73, then again 79, then the last is 73. So when we talk about the 73 units, that is the level of output which shows the higher level of output, and when we talk about the higher level of output, we talk about the higher isoquants. So any farm which produces the higher level of outputs, that calls the higher isoquants. So this is a way that how you represent you can see in the schedule, and in the from the schedule itself you can represent the graphical representation when it comes to the schedule, and this is a way that how you portray the higher isoquants from within the schedule, and accordingly you can draw the isoquant curve as well in the form of boxes and in the form of trend lines, you can see, and that's called the higher isoquants, which represents the higher output. So this is called the economic reason of production. So when you have a schedule and with the production function with two variable inputs, and this is the way that how the isoquant curves has been drawn. If you look at the previous you can say slide, the same example has been followed in the upcoming slides, which to portray the economic reason of production and which has been shown on the screen. And this is the way that how you represent when it comes to show a schedule, and from the schedule a particular learner has to represent that schedule and draw the isoquant curve using that particular data. So if you look at the first isoquant, so this is a way that how within the schedule you can also draw the isoquant curve by putting up a trend line and putting up the boxes in of the numbers. So if you look at the first curve, that is 12, 12, and again 12 by combining the two inputs, labor and capital. So if we talk about the second curve is 28. Why we have chosen 28? Because they are producing the same level of output if a particular is combining two inputs. Same for the third category, same for the fourth isoquant, so which has been shown 12, 28, 36, and 40. So when we talk about the economic reason of production is that portion of the isoquant which has a negatively sloped. So if you look at the portion which portray or which shows the negatively slope, that particular area is called the economic reason of production. So in the upcoming slide, this is called the economic of reason, and you have to draw the ridge lines. Ridge lines portray or shows that covers that portion of the isoquants which having a negatively sloped curve. So if you see the four isoquants from lower to higher isoquants with their respective level of output, so you can see the ridge lines has been drawn, the area, that portion has been drawn where the curves or where the isoquants curve which shows a negatively sloping, and that particular area is called the economic reason of production. So if you see on the screen, the four isoquants curve has been drawn where the particular curves which has been touched, the ridge lines has been drawn which covers the portion of all the isoquants which is a negatively or having a negatively sloped curve in the form of drawing the ridge lines. Ridge lines are those lines which shows in the isoquants curve, and that covers the portion of isoquants having the or by the combination of two inputs, that is labor and capital. So if you look at the curve, the ridge lines has been cut off to the 36 isoquants curve, as why it has the points has been drawn Z, V, and U, because that particular exact curve with almost showing a more negatively sloped portion, and that's why the points has been drawn, that is Z, Y, and U, and of course I. So this is the portion which refers to the economic reason of production, where the labor has been measured on the x-axis and capital has been measured on the y-axis. So while combining the two inputs, labor and capital, the isoquants curves has been drawn which that produces the same level of output, that is the 12, 28 units, 36 units, and 40 units. So the economic reason refers to that portion of isoquants that have a negatively slope. So in the particular diagram, the ridge lines has been drawn where the isoquants curve portraying or showing the negatively sloped curves which shows in the form of the ridge lines and cuts the isoquants curve which portray the most negatively isoquants curve, that is the 36 units, or produces a level of output that is ZYU. So this is called a graphical representation. It refers to economic reason of production while combining the two units. So the curve which has been drawn or showing, or the portion which has been shown in the isoquants curve, that particular lines are called the ridge lines, and that under the ridge lines, the portion which has been covered, that portion or that region is called the economic reason of production. So now we come to that substitution of two inputs. If we categorize to the substitution, there are three main categories. The first one is perfect substitution, the perfect complementary, and the imperfect substitution. So when we talk about the substitution or substituting the inputs, there exists some degree. Always be when we talk about the two inputs, always have some degree of substitutability between these inputs, and various types of these substitution has been shown on the screen. The first one is perfect substitution, when it shows you can see the dotted line where the sugar and the corn has perfect substitute to each other, and in fact where the two combination of inputs is being you can see covers the total cost, which increases or decreases accordingly and influence to both inputs. But when we talk about the perfect complementary, which covers the, you can see the L shape, I could say, which is the level of output where the, if the natural flavoring some of the ice creams or the products, it goes, you can say down, then automatically the quantity of all other integrants of that particular products would be the horizontal, and that's called the perfect complementary. That one, if there is any change in one particular input, automatically it will get changed in the another input or other integrants. So when we talk about the imperfect substitution, so automatically we talk about the more or less input of another input. If there is any change in one input, it could be more or less to a change of another input. That is capital N labor. If you look at the imperfect substitution, so if any change in capital is more than the change in labor, or any change in labor is less than or more than the change in capital, so that's called the imperfect substitution. So when we talk about the perfect substitution, if there is 1% change in one input, then automatically it would also influenced by 1% change in another input. Same in another case, but when we talk about the, that's called the perfect substitution. But when we talk about the imperfect substitution, so we always talk about the more and less changes in between or among the two inputs, that is labor and capital, and that's the main reason that the isoquants curve is automatically called a downward sloping curve, which has been shown in the yellow portion, which produces the level of output. And that's, if you see the capital P1, P2, P3, and P4, or L1, L2, L3, and L4. So if you see the differences, range of differences between the units of labor and capital, it would be more and less, and that's called the imperfect substitution. So these are the three categories of substitution, which shows the perfect substitution, perfect complementary, and imperfect substitutions, which has been shown in these particular diagrams or separate diagrams with the follow-up examples, so that it portray or convey that how the two input will substitute to each other, following up these main categories or degrees of substitution. Next concept is isocost line. So before I come to the diagrammatic representation or any schedule related to this particular concept, so but learners must understand what is the isocost lines. What is the isocost line is? It is the locus of all those points of different combinations of level of you can say labor and capital that the firm can produce while giving up the total cost and the prices. So in simple words, I could say it shows a combination, all combination of all those inputs that the firm will use and able to produce or purchase with a same total cost, and that particular line is called isocost lines. For example, there are two prices has been given. The price of a labor is wages and the price of a capital is interest, which symbolically represent W for wages and interest R for interest. And the total cost, how to calculate the total cost by using these prices by the firm which has been given, the budget line or in the ISO cost line. So before it's just a combination or a locus of points where the points or the dots has been drawn which shows a combination so the firm can purchase or produce given the or you can see the prices as well as the total cost. But when we talk about symbolically, it represents by W and R when it talks about the prices of equation of the isocost line is C stands for cost is equal to wage, that means WL, that is the price of wage, price of labor is wages, that stands for WL, plus RK, the price of capital is interest, and the R is refers to interest, that is RK. So when we combine these prices and relate it with respect to the cost, by combining the labor and capital, and that line is called symbolically or mathematically equation, that is isocost line. So when we talk about the budget line, the prices of x and the prices of y, that is y, that's when we combine the prices and the income, that's called the budget line. That is symbolically M is equal, that is the budget is equal to the px into x plus py into y, and that stands for budget line. But how it will show the graphically, this is the graphical representation of the isocost lines. So if you look at the isocost curves, there are two main curves has been drawn, which has been called a perfect substitutes, the isocost curves. As there is a 1% change of labor, automatically there would be a 1% change of capital, and that's called the perfect substitute. And if there is a little change in the labor, it automatically have an or influence a little change in the capital in the labor. So this is called, and that budget line, this is called the isocost line, which shows AB in the form of symbolically, namely AB. That is from 10. If you combine the two inputs, labor and capital, that produces the 10 units. That is level of input. So the perfect substitute, if there is any change in capital, there is a change in labor, which has been shown as minus 1k. That would be the 1L. That means minus 1L would be the change of that. Now, isocost line where the in the second graph, if there the cost is given and the even the interest and the wage is equal in the second category, there is equal in the third category, there is equal. If there is a change in the wages and the interest, then automatically the isocost line will shift parallel to the another in the form of another isocost line, that is AB to AB dash. I repeat, if there is any decrease in the prices, the isocost curve or isocost line will shift or will have a parallel shift. You can see towards the outward shift. When there is an increase in the prices of the particular product, then that means the isocost line will shift or will shift a parallel to the backward shift that's called the increase that results to an increase in the particular prices of a particular labor or capital. So this is the overview where the three isocost line has been drawn, that is AB, A dash, B dash, A dash dash, and B dash dash. So this is the two main curves has been drawn. If there is any decrease in the prices, the isocost line shifts rightward. If there any increase in the prices, the isocost line will shift to the backward. When there is any change in the particular one of the capital or the labor, or if we say there is an increase in the capital, whereas no change in the labor, it automatically shifts the isocost line, which is called the parallel shift of the upward towards the upward, that's called the AB dash. If you look at the price of the wages is 10, a price of the wages is 10. Now in the fourth particular situation, the price of the wages is become decreased from rupees 10 to rupees 5. As a result, the particular isocost line will have a or having a parallel, you can say left rightward shift, which refers to AB dash. And when there is a decrease in the prices of any of the inputs, it shows that the isocost line will shift parallel to the outward side or rightward side. If there is an increase in the prices of any of the input, that the same isocost line will have a parallel shift to the leftward side, and that's called the graphical representation of the isocost lines. So if you look there, the first curve, that is a perfect substitute. But if you talk about the second curve, there is a, you can say, changes in the substitution of any of the inputs, that is labor and capital. So when there is a change in the prices, the isocost line will shift immediately to the parallel rightward or leftward shift. And that's the main reason when there is a parallel shift, a mathematical equation would occur, that is k is equal to C by R minus W by R labor. As C refers to cost, R is referred to rate of interest, W is referred to wages, and when it's called labor, L stands for labor. So when you subtract to each other, you will get the capital, a change of capital amount. When we talk about C by R, cost by interest, we talk about, it's called the intercept. When we talk about the slope, we talk about the wages by interest into labor, that's called slope of isocost line, and intercept of isocost line. So this is a mathematical formula which will be used if the C has been given, R has been given, so automatically you can calculate the intercept of isocost line. If this W is given, R is given, and L is also given, you can easily get the slope of the isocost line in respect of capital, and intercept of isocost line in respect of the capital, that stands for K. So this is called the graphical representation of isocost line having a perfect or imperfect substitute of two inputs. So if there is any changes, automatically it influences the curves. Now we talk about the theoretical concept of the intercept and the slope of isocost line. So what it already shown here when we talk about intercept, we always refer C by R, and we talk about the intercept of the isoquant on the labor, it's called the C by W. So basically, what is the intercept of the isocost line in respect of one input's namely capital, and what is the meaning of intercept of you can say isocost line in respect of the labor? So basically, intercept refers the maximum amount of capital or the maximum amount of labor has been used when if we talk about the intercept of isocost line in respect of the capital, it refers the maximum amount of capital which has been used when labor is not used in the production process. That means the labor become unchanged, and that's called the intercept, which is given by C by R. But when we talk about the intercept on the labor axis, which is the maximum amount of labor used in the production process, and it is given by C by W. So it automatically, when we talk about the capital intercept, it refers the maximum amount of capital. It means the maximum changes in the capital which is being used. When there is no change, then there is no use of labor. But when we talk about the intercept of the labor axis, which is the maximum amount of labor which is used in the production process, and there is no role of the capital, or the capital is not being used in the production process, it's given by C by W. So this is called the exact meaning of intercept of isocost line in respect of the capital and the labor. So when we talk about the slope of the isocost line, so this is the slope, that is the price of labor by price of capital, that means that W by R. So here we talk about the slope, that is W by R, rather than we talk about C by R. So C by R is the intercept of in case of labor. C by W is the intercept of the labor, because R stands for the capital and W stands for the labor. So as a result, the isocost line here we are talking about the prices of both labor and capital, that is W by R, and that's called the slope of the isocost line. Next is why on what basis the changes occurs in the isocost line. So if any changes in the prices, there is a shift in the isocost line. If there is any changes in the labor, I've taught there is a parallel shift of the isocost line. That means wages. If we talk about labor, we talk about wages. If we talk about capital, we talk about interest. So when we talk about the total cost, so there is a right, you can say rightward shift and the leftward shift. So when we talk about the prices, we talk about the wages. There is a parallel shift of the isocost curves. So let's begin the changes in the isocost line. The changes with occur following up the two factors, that is the total cost and the price of labor. If there is any changes in the total cost, for example, a decrease in the total cost, that means that particular isocost line will shift to the leftward. If there is an increase, that it shifts to the rightward or outward shift, or you can say inward shift or the leftward shift. So that's called the concept of the changes in total cost, and it automatically shifts the isocost line from inward or outward. If the particular price or the particular cost will increase from 400 to 500, it shifts to outward. If it decreases from 400 to 300, shifts to inward. So this is called the change. If there is any changes in the total cost, automatically it will parallel inward shift or parallel outward shift in the total cost. But when we talk about the changes in the price of the labor, so automatically it will parallel shift and begin from the same point. That's called the changes in the price of labor. So if the labor price is become you can say falls from 3 4 to 5, or you can say falls from 4 to 3, the isocost line shifts outwards and it begins from the same original budget line. So if the original budget line is 50, so the particular curve, isocost curve will also, yeah, or isocost line will also shifts to the outward, which begins from the original isoquince curve, that is 50. So if there is an increase, so automatically it's you can see shifts to the inwards and it begins from the original isocost line only, and that's called, and that results or due to the changes in the price of labor. So if you look, if there is any decrease in the prices of labor, L rotates the isocost line counterclockwise. It is called, if there is a decrease 4 to 3, this is, in other words, it is called the counterclockwise isocost line. But when we talk about increase, it's called the budget line clockwise. So that will be shifts to the inwards, right? From the begin from the original isocost line, which is called 5060, and the labor is 50. So this is the graphical representation when there is a changes in the total cost or when there is changes in the price of labor. So this is the exact graphical representation when there is a changes in these two factors, total cost and the price of labor. So this is also, when we talk about the optimum combination of inputs, we always talk about the producer equilibrium. We will not talk about the consumer equilibrium, because when we talk about the consumer equilibrium, we always talk about the ice production function with one input. But when we talk about the combination of two inputs, we always talk about the producer equilibrium. When we talk about in the long run, there is a major concept. Talk about the marginal rate of technical substitution, that is with respect of the about combination of two inputs, labor and capital. So if there is any change in the capital, it automatically change the units of labor. So when we talk about even the slope is also the same. When we talk about under the marginal rate of technical substitution, the slope of isoquant and the slope of isocost line will become equal. So when both are equal, so automatically the slope of the isocost line, which is W stands for wages and R stands for interest, R, you can say W by R, that also equals to the marginal rate of technical substitution. So that is the you can say the mathematical equation where the MRTS LKS with respect to labor and capital is equal to minus delta K by delta L. When any calculations mathematically, the minus you can say it could come the marginal rate of technical substitution. As we decreasing the capital, so automatically it increases the labor. Or if we decreases the labor, automatically it will increase the capital in some degree of it. So that's also equal to wages by R. So if you look at the diagram, there are three budget lines or isocost lines has been drawn in the form of AB is the original isocost line, A dash and B dash. This is called you can say rightward or the outward shift. Why there is an outward shift? Because automatically it was gone increase into an output. When we talk about the next concept, A dash dash and B dash dash, that is the rightward shift or the inward shift of the budget line. So when we talk about the isoquants curving from the center of the isopost line, the isoquants curve, which is convex to the origin, or you can say which is shown to a negatively slope, or you can say the proper you can say downward sloping curve, that's called the isoquant, which has been shown over on the budget or the isocost line. So if you look at the budget or isocost line, the particular isoquant has been drawn at the center of the each isoquant line. So if you look at the isoquant of 14Q, isoquant of 16Q, and isoquant of 8Q. So this is based on the assumption is 8 is a lower, then it keeps increasing to the higher isoquant, and again the higher isoquant, that is 14. So it is being drawn at the center of the isocost line, that's called the isoquants curve. So once the isoquants curve has been drawn at the center of the isocost line, that centered points, and once a ridge line has been drawn, which is begin from the origin, that line or that interaction of the isoquant and the isoquant line and the isoquant curve is called expansion path, and these points are called the optimum combination of inputs in respect of the labor and capital. So when we talk about the optimum level of output, it stands E. Why? Because AB is the original budget line, and on the original budget line, where the isoquant curve intersect at the center of the point, and that point, namely that is E, and that point is called the equilibrium point, which shows the optimum combination of both inputs, labor and capital, which has been shown, that is the particular labor is 5 and the capital is 5. That means whatever the point where the labor and capital has been combined always produces the same level of output, and that's called the optimum combination of output by combining the two variable inputs, labor and capital. So if we go forward the isoquist curves, then automatically it will you can see higher isoquants, that is 14s. So this is a graphical representation in case of producer equilibrium having an condition optimum combination of inputs. So this is the main reason that if you increase any, you can say price of a labor, it automatically it changes the price of a capital. So if you see the main optimum level is E, where the produces the same level of output, that is by combining these two inputs, that is 5 unit level of output. So when we talk about the 8K and 14K, these are the points where by combining these points, which shows the expansion path, which shows a way where a particular level of output could be produced by combining these two inputs. So if we talk about the level of labor, so you can also see the exact the changes of the budget lines, where the outward shift and the inward shift, the difference between or the changes between is more and less. So that's why the level of output could be the different among these changes due to the changes, but that's not, that's why the F or D will not consider the optimum level of inputs. and especially the E refers to an optimum level of input because it occurs on the original budget lines, and when it comes to original budget lines and the curves, by combining it, that's called the optimum level of input at a 5 units level of output by using these two variable inputs. And marginal rate of technical substitution is one of the conceptual framework which will be used as a in case of producer equilibrium. Well, when a producer equilibrium point will shown in a particular diagram which is shown on the screen, that's called the optimum combination of two inputs. What is producer equilibrium? Producer equilibrium shows a lowest cost producing a given level of output. So if you can look at the diagram, of course, if where there is a shifts in the isocost lines, whether outward or inward, but then also the producer equilibrium produces the lowest level of output, that is the 5 units of output as compared to the 14 units of outputs or 15 units of outputs by combining these two inputs, labor and capital. And that's why producer equilibrium shows a lowest cost of producing a given level of output corresponding to an output which is tangent to the isocost line. So look at that these are the tangent of the isocost line, the curves, which refers to 10 for the capital, 10 for the labor, 14 for the capital, 14 for the labor, 8 for the capital, then 8 for the labor. So equilibrium point, we have to find out that which level of output, that is 5. So that is called the producer equilibrium, which is tangent to the isocost line output. They are both substitute to each other, and as a result this substitution shows a relationship which in the form of MRTS, which refers to minus delta K by delta L, that stands for MPL by MPK. MP stands for marginal product, and which also equals to the price of labor and price of capital, and ultimately is equal to the slope of the isocost line, that is wages by interest. R is interest, W is wages. So automatically both are equal to each other. So if you classify the Moore equation, the end of the equation is marginal product of labor by W, that is wages, that is the price of labor. When we talk is equal to the marginal product of capital by R, that is R marginal product of capital by interest. So whatever the production would process of labor or capital. Accordingly, their prices will also include in that in the form of wages and interest. These are optimal level of inputs, the optimality conditions as in the previous slides, which has been always showed the least level of outputs. That's called the optimum level of inputs by combining those particular factors inputs. How much the output should be producing, the firm will produce, that depends upon the optimum level of inputs by combining it. If you see the previous slides in the diagram, the 5 units level of output, so accordingly the firm will also produce the 5 units level of output based on the situation or the conditions and the time period. So this is a way that how it depends, and accordingly, when we answer this question, it also depends upon the demand of that particular product. Like if, like for example, if one having a one demand of input, that is capital, then automatically the labor will also get involved. After all, the prices of both will also included when it comes or reach to an optimum level of inputs. So automatically how much the firm depends upon the optimum level, and of course the other factors also, that is the demand of that particular product. which also includes the one input as the case may be. So that's called the optimal level of inputs. What is expansion path? As I already told, the expansion path is refers to a locus point by of all the combination of inputs that refers to a lowest possible isocost lines. So automatically how the expansion path would begin. It's begin from the origin, and origin is the lowest point which always begin from the lowest isocost line and keeps moving forward to the highest, and that line, that path is called which intersect the which cuts the intersection points of the isocost line and the isocost curve, and that points, that line is called the expansion path, that locus of points of all the equilibriums points of isoquant which shows a possible lowest isocost line, that's called the expansion path. In other words, also it refers to all those costs involved in minimizing the inputs combination of various levels of outputs that the firm can produce in the long run, and that's called the meaning of expansion path. This is a graphical representation of it. So if you look at the budget lines or isocost line and the isoquants curve which intersect at the midpoint, and that midpoints it's called, and that line which has been drawn on the midpoints, that points is called the expansion path. In the long run situation where all two factors are variable, so when we talk about the combination of two factors, it's called variable. So the black portion which has been drawn, that's called the optimal portion, where the firm can produce these units at the center point of the original budget line, at the center point firm can produce, and also depends upon the demand by follow up the one or other inputs as the case may be. So this is a graphical representation when it's come to the long run situation when both factors are variable. So it's very similar, and this line is also called the expansion path, which refers to a locus, a combination points of all the isoquants. So if you look at the diagram, it's locus points of all the combination of the isoquant curves and the isocost line, which refers to lowest possible isocost curves or cost, and that's for that particular path, that ridge line is called expansion path, by using the concept of the long run situation where both inputs are variable. Now we talk about the difference between the producer equilibrium and consumer equilibrium. So these are the differences. So when we talk about the producer equilibrium, we talk about the producer's theory, that how much the firm could produce the same level of output by combining the two inputs. How to maximize the output. The major objective of the firm to maximize the output. The major concepts that involve or to obtain the maximum or optimum level of output, that is the isoquant curves, the isocost line, expansion path, the condition of equilibrium, that is MRTS is equal to minus delta K minus delta L, which also equals to W by R. That is the prices of labor by prices of interest. So when we talk about the consumer, we always talk about the consumer's theory, the motivational theories, how they satisfy the needs and wants, and automatically the one of the major objective of the consumer and how they maximize their satisfaction. Under this category, the indifference curve and the budget lines will occur. We'll follow up this concept and graphs. Income consumption curves or price consumption curves will be used. Equilibrium condition, that is MR, that is marginal rate of substitution, is equal to delta Y by delta X is equal to price of X by price of Y. Where we talk about the budget line, where we talk about the money income with respect of the prices of X and Y of two variables X and Y. So that is called the consumer equilibrium, where the producer aim is to maximize the output rather than satisfaction, but the consumer aim is to maximize their satisfaction, and accordingly, firm will always try to maximize the consumer satisfaction, and on that basis, the various conceptual framework or diagrammatic works of indifference curves and budget line were used. So accordingly, this is the main difference between the producer and consumer equilibrium. So here, the both concepts are totally different. So it cannot be combined at any level or in any way at all. So here, if we talk about, always the students have a misconception if the marginal rate of substitution and marginal rate of technical substitution. So both are same exactly. The students thinks like that, but no, it's not at all the same, because the marginal rate of substitution, here we are talking about the two variables, that is X and Y. But producer, here we are talking about the two factor inputs, which are always be variable, always be changing according to the time and situation in the long run. But when we talk about the consumer, here we consider the prices of two variables. But producer equilibrium, here we are considering the prices of the two factor inputs, that is labor and capital, wages and interest. Here we talk about the measurements of returns to scale. So if we talk about the returns to scales, that comes in the long run only. So how to measure the returns to scales? That is of any percentage change in, it refers to a percentage change in output due to a percentage change in all the inputs. So when we talk about the three categories, the three degrees of returns to scale, that is increasing returns to scale, constant returns to scale, and decreasing returns. So when we talk about the increased returns to scale, so if there is any change in output, change in output is more than the change in inputs. It's called increasing returns. Change in output, it's same to a change in inputs, is constant returns. If any change in output is less than the change in input, is called a decreasing return. In a very simple words, if you want to more elaborate, or instead of having to write up the change word, you can write up the increase in output, decrease in output. So if talk about the increasing returns, if any increase in output is more than the increase in inputs, is called increasing. If there is an increase in output is same as an increase in inputs, is constant returns. If any increase in output is less than the increase in inputs, it's decreasing returns. So this is a way that how you can say elaborate these three concepts based on the follow up the formula which measures the returns to scale. So these are the particular reasons for increasing returns to scale and decreasing returns to scales. The first one is how you divide the labor according to their specialization, how you indivisibility of machinery. The most sophisticated machineries would be justified in economies of scales, where the expansion part, the combination of two inputs, which produces the same level of output. That the reasons that how the output and input would get proportionate increase or more than that of it. But when we talk about the decreasing returns to scale, it's of course the inefficiencies would occur. A problem if communication and how to increase the user fix factor. So till time, that's all for today. Thank you for listening this lecture and namaste to all.